Hello everyone, it's Arnav here, and today we'll be going over the 2023-2024 Virtual Challenge Meet number 4 for the physics section. So I'll be going over all 20 questions on this section, and before I get started, I would like for you all to try this test, try all 20 questions on your own to get you guys to have a feel for the test, and to make sure you guys know which questions you're struggling with and which questions you don't need help with. These are current questions from numbers 1 through 7. These are the questions from number 8 through 13. And these are the questions from numbers 14 through 18. And these are the last two questions. And then this is the formula sheet that you will be needing for all of these questions. The first three questions come straight from the year's reading for Science UIL. So this year it's 5 equations that change the world, but at the time of viewing this video, it might be a different reading for you guys. So the only way to answer the first 3 questions is just to go over the chapter that you're assigned. So the answer to number 1 is going to be letter C. The answer to number 2 is going to be letter E. Answer to number 3 is going to be letter A. Number 4. Given that the observed peak of the sun's spectrum is 500 nanometers, use Wayne's law to estimate the surface temperature of the sun. So, the fourth question is always going to be an astronomy question, but this one is more, you're going to need a formula for this one, so it's not really memorizing a random fact. To find Wayne's law states that the maximum wavelength of light equals Wayne's constant, which is going to be 0.0029, divided by the maximum temperature in Kelvin. So we know that the maximum wavelength, which is the peak, so I'll say this one is peak wavelength, and then T would be the temperature. Remember, temperature in physics most of the time is always going to be in Kelvin. So this is another example of it having to be in Kelvin. Just solve for temperature. You would get 0.0029 divided by the wavelength, which is 500 nanometers. Convert that into meters, because in physics, the standard unit for distance is always meters. So 500. So the final answer, you get temperature as 5,800 Kelvin. So the answer to number 4 is going to be letter B. Number 5. 46.7 megameters equals how many nanometers? So on the right hand side, we have this conversion table where we see all the prefixes that we're going to be using. So the most common ones that you will 100% need to memorize for this exam are going to be kilo, centi, milli, micro, and nano. And you will need to memorize the symbols too for these prefixes. But for this question, obviously, yes, we'll need to know what mega is too. So let's just do conversions. So 46.7 megameters. Let's convert this to meters, because meters is the baseline. Let's convert that into meters, and then we'll convert meters into nanometers. So 1 megameter is how many meters? If we look at the chart, 1 megameter is 10 to the power of 6 meters. So 1 megameter is equal to 10 to the power of 6 meters. And now we want to convert meters to nanometers. So 1 meter is how many nanometers? So 1 meter is how many nanometers? We know there are 10 to the power of negative 9 meters in 1 nanometer. So that means 10 to the power of negative 9 meters per nanometer. But we want the opposite. We want to find in 1 meter how many nanometers. That would be 10 to the power of positive 9 nanometers. So we can multiply this by 10 to the power of positive 9. 10 to the power of positive 9 nanometers. And then just solving the equation, you would get 46.7 times 10 to the power of 15. But you want to write this in scientific formation, where the decimal has to be less than 10. So you would write this as 46.7. No, wait. No. 4.67 times 10 to the power of 16. So this would be your final answer. D. Number 6. The punter for the Groover Greyhounds kicked the football against the Booker Fighting Kiowas. The ball left his foot 86.5 centimeters above the ground at a speed of 22 meters per second at an angle of 46 degrees above the horizontal. If the return man let the ball hit the ground, how far from the punter did the ball hit the ground? So let's diagram this problem. We have a football that's going at a velocity of 22 meters per second at an angle of 46.6 degrees. The ball is initially at a height of, let's say this is the turf. Initial height is going to be 0.865 meters. So with that in mind, eventually the ball is going to fall because of gravity and it's going to hit the ground. We're trying to find the distance between the ball and the ground, the kicker and the ground. That's what we're trying to find. So, how do we solve for D? Well, because when you think about it conceptually, when a ball, the only force that's acting on the ball is gravity. That's one thing you have to keep in mind. The only force acting on it is going to be gravity. Gravity points only in the y direction. It does not point in the x direction, meaning the x component of this ball, which I'll discuss later, right here, the x component of this ball, which is this right here, the velocity in the x direction, how far the ball travels straight to the right, that does not change. It stays the same. It stays the same, so we write that as velocity in the x direction times time. This is the formula we want. Distance equals velocity times time. Velocity in the x direction. Because this stays the same. But we know this that the arrows are pointing down, meaning it is affecting the velocity in the y direction. The velocity in the y direction is initially positive, but eventually becomes negative as the gravity pulls it down. It's the velocity in the y direction. So first let's solve for velocity in the x direction. To solve for that, it's just basic trigonometry, where cosine of 46.6 equals adjacent over hypotenuse. Solving for v of x would equal 22 cosine 46.6, 15.116 meters per second. Move that to the side. So now we know the initial velocity in the x direction. Now we want to find time. How long does it take for the ball to hit the ground? We can use this kinematic equation. Change in the height of the ball equals the initial velocity times time plus 1/2 times acceleration times time squared. This kinematic equation right here. So what does this mean? What does delta y mean? Delta y is the final y value minus initial y value. So what is final and initial? So the final height is 0. It lands on the ground. It says if it hits the ground. So the initial height, the final height is 0. The initial height is going to be 0.865 meters. So delta y is negative 0.865. What is the initial velocity? It's not this. You might be tempted to say just the one we calculated. It is not that. It's the initial velocity in the y direction because we're looking at the y component where the ball goes up. Because we're talking about how long it takes to hit the ground and gravity is involved in that. So we're looking at the y component. We can calculate that by using the same method with the x component. Sine of 46.6 equals velocity, the y component divided by 22, and the y component would be equal to 15.985. So v of y equals 15.985 meters per second. Move that up and we'll plug that in. So 15.985 times time, which we're trying to find, plus 1/2 times, what's acceleration? On Earth, you've heard of the acceleration due to gravity equaling 9.8 meters per second squared. But we can't just plug in 9.8. And the reason why we can't just plug in 9.8 is because it's pointing down. Because the arrows are going against the initial velocity. It's pointing down. It's making the initial velocity negative. So the acceleration would actually be negative 9.8 times time squared. So now with all this in mind, we want to find time. So bringing everything to one side, this is equal to negative 4.9 t squared. So bring that to one side, you get 4.9 t squared minus 15.988 t minus 0.865 equals 0. And now it's down to the quadratic formula. As you can see, we made a quadratic equation here. So we want to solve for t. So that would equal minus b plus or minus the square root of b squared minus 4ac 2a. Standard quadratic formula. Solving for that would give you doing the math, you would get time equals 3.316 seconds. That's how long it takes for the ball to hit the ground. Plugging that into our initial equation, 3.316, and solving for the displacement of the x value, you would get 50.126 meters. So the answer to the question at the very end is going to be this: 50.126, which is round closest to 50.1. So the answer to number 6 is going to be E. Number 7. When the 1.5 kilogram block is released, the 3 kilogram block accelerates across the tabletop at 1.45 meters per second squared. Find the coefficient of sliding friction between the tabletop and the 3 kilogram block. Assume that the pulley is frictionless and massless. So, we are given that, well, actually, let's first draw the arrows, because that's what we do in any physics problem. Let's call this mass of y, and let's call this block mass of x. weight force is what brings the block, this mass right here, down. Weight is what brings it downwards. And weight is equal to mass times gravity. So we'll make sure this is mass of y times gravity. There's always going to be tension force on any that points away from any object that has mass. So there would be a tension force here too. And the problem states that there is some friction force, as we were trying to find the coefficient of sliding friction. Friction force can be written as the coefficient of friction times the normal force. And because the object is sitting directly on the surface, normal force and weight equal each other. So normal force is actually equal to weight. And we know the weight is equal to mass times gravity. So the normal force would be mass times gravity. This time it would be mass of x times gravity. And we know that there's two net forces. There's going to be net force this way. So net, that's equal to the mass of x times acceleration. And there'll be net force this way. So net x, net y. Net y would be similar. It would be mass of y times acceleration. So, with that, everything in mind. Net force in the x direction equals mass of x times acceleration. Net force is also equal to tension minus the force of friction. And we calculate a force of friction to be the coefficient times the mass of x times gravity. So this is what we need to focus on. And what about the net force in the y direction? Same thing. Mass of the object y times acceleration. That would equal weight, which is equal to mass of y times gravity minus tension. So we don't need these anymore. These are the two formulas we're trying to focus on. We want to substitute, at this step we want to substitute t. So we can rewrite the first equation to be t equals mass of x times acceleration plus the coefficient of friction times mass of x times gravity. That's what t equals, and then substitute that to the second equation. So now you would get, let's move that this way, you would get mass of y times a equals mass of y times g minus the substituted value of t. Mass of x times a plus the coefficient of friction times mass of y times g. So now we're trying to find the coefficient, so we want to isolate the coefficient. Let's first distribute the negative sign, so now you have this equation. Let's try to bring this guy to this side, or bring this guy to the other side, because we want to isolate the coefficient. That's our goal. Mass times y, mass of y times gravity, equals the mass of y times gravity minus the mass of x times acceleration minus the mass of y times acceleration. Final step is to divide both sides by mass of y times gravity. So you will get the coefficient of friction equals the mass of y times gravity minus the mass of x times acceleration minus the mass of y times acceleration over the mass of y times gravity. So final step is just to plug everything we know in. So we know mass of x equals 3, mass of y equals 1.5, acceleration equals 1.45, and we know gravity equals to 9.8. So plugging everything in that we know, we can get final answer for this question would be 0.278. So the answer to number 7 would be equal to A, 0.278. Number 8. A 1,250 kilogram car is traveling up on a road that is inclined at 8.25 degrees above the vertical. The car is at a constant speed of 90 kilometers per hour. With a constant retarding force of 725 newtons as the car travels on the road. Find the minimum power required. So let's draw the figure on the right. So you have the car. So the green line's at ground level and the car is at an angle of 8.25 degrees. What are all the forces on this car? Actually, let's work backwards a little bit before we find, we're trying to find minimum power. So what is power? Power is equal to the work done by an object divided by time. And what is work? Work is equal to force on the object times displacement of the object. So we can replace work with force times displacement. So rewriting that, you would get force times displacement over time. And displacement over time, displacement in this case would be considered distance. So distance over time we would get speed, or velocity. So force times velocity equals power. That's what we're trying to find. So power equals force times velocity. In this case, it would actually be net force. Don't just write force. Net force times velocity, and we have the velocity already. The velocity is given to us as 90 kilometers per hour. So we have the velocity, but we need to find net force now. So what are all the forces acting on this car? We have the weight force, as usual. Since the car is on an incline, remember, normal force is always perpendicular to the surface. So if we zoom in, we want to draw a line perpendicular to the surface, we would get something like this. It's not my best, but yeah, perpendicular to the surface. So the blue line's your normal force. The arrows are not meant to scale, by the way. So where this is perpendicular. That's perpendicular. So, and there's also a retarding force. There's also drawn in brown, there's this retarding force. We want to find net force. What is the net force on the car? We can break the weight into two components. We can break the weight into one component that's perpendicular to the surface and one component that's parallel to the surface. So the brown line I just drew right here, that's parallel to the surface, the black surface. And the green line's also as perpendicular to the black road. So if we have one line that's perpendicular to a surface and one line's parallel to the surface, that means they would have to be perpendicular. So these two are perpendicular. I'll redraw that triangle down here. So you have a green line, a brown line, and a red line. The red line is equal to mass times gravity. And you have a right angle here. Another thing you have to note is that the angle right here between the red and the green line is equal to the incline angle, since these two are similar triangles. So this angle over here would be 8.20. Actually, I'll draw that triangle a bit bigger. So 8.25 you have mass times gravity. This would be mass times gravity cosine of 8.25. This would be mass times gravity times sine of 8.25. So, we know that the normal force right here, we know that the normal force, the blue line, cancels out with the green line because they're equal in opposite directions. So, we can erase weight because weight is broken down into components, and we can erase the green line and the blue line because they cancel each other out. You can see that the net force is just the retarding force and the Brown weight component, which we know is mass times gravity times sine of 8.25. So net force is equal to the retarding force plus mass times gravity times sine of the angle, which is in this case 8.25. So retarding force is given as 725. The mass of the car is 1250. And the gravitational constant on Earth is 9.8. So plugging everything into a calculator, you would get net force equals 2,482.785 newtons. That's net force. So we want to find net force times velocity. We found both of them. So power equals power equals net force times velocity. But there's one thing we have to keep in mind. That net force has to be in newtons and velocity has to be in meters per second for you to get watts. So we have to convert the velocity from 90 kilometers per hour to meters per second. So I'll zoom in a little like this. Times 1,000 meters in 1 kilometer, and there is 3,600 seconds in 1 hour. .25 meters per second. So the net force is going to be 2,482.785, and the velocity is 25 meters per second. So you get 62,069.615 watts. That's the power. But we want power to be in horsepowers, not watts. So if we look at the formula sheet, actually I'll just keep this and if we look at the formula sheet, we have 746 watts in 1 horsepower. So using that conversion, 62069.615 times 746 watts for 1 horsepower, you would get 83.203 horsepower. So the answer to number 8 is going to be 83.2. So the answer is C. Number 9. A 6-meter long ladder leans against a wall at a point 4.8 meters above the ground. The ladder is uniform and has a mass of 14 kilograms. The base of the ladder is 3.6 meters from the wall. Assume there is no friction between the ladder and the wall. The coefficient of static friction between the ground and the base of the ladder is 0.425. How far up the ladder can a 60-kilogram person climb without the ladder slipping? So, what is the question trying to ask? The question is asking how far can a person stand such that if he goes any further, the ladder will slip. But this is like the maximum length it can go. It's essentially when all the torques balance each other out, when everything balances each other out, such that if this person goes even a little bit more, the ladder will fall. So it's pretty much the maximum height you can go. So, like every physics problem, let's label all the forces we have. Before that, actually, let me make sure to draw the side lengths. So you have 6, 4.8, and 3.6. And so what do we have? What are all the forces? We know that the problem did say that there is friction between the ground and the base of the ladder. There is static friction. So there is a force of friction coming this way. And there is a weight force on both the ladder's center, which I'll draw in this red circle, and the person, which I'll draw in the actually I'll draw in a different arrow. I'll draw in a black arrow. So there is the weight of the ladder and the weight of the person. Those are two forces. There's remember, any object that's sitting on a flat horizontal plane, will experience normal force. So there's going to be normal force here. And as you can see, if you look carefully, this ladder is pushing on the wall. So according to Newton's third law, forces occur in equal and opposite pairs. If the ladder pushes on the wall pushes on the ladder. So there's going to be a force applied by the wall. And these are all the forces we have. It looks like a lot, but we can simplify this really well. We know that this is all in equilibrium because that's what we're trying to find, the height where at this height everything's balancing out and everything balances each other out. So let's look at the vertical forces first. Normal force, weight of the ladder, and weight of the person. So we know normal force points up, the weight of the ladder and the weight of the person point down. That means the normal force has to equal the weight of the ladder plus the weight of the person, because of the arrows opposite directions. So the weight of the ladder, remember the formula for weight is equal to mass times gravity. The mass of the ladder is 14. Gravitational constant is 9.8. The mass of the person is 60. And same thing, 9.8. So that means normal force is equal to 725.2 newtons. That's normal force. So what do we do from here? What about the horizontal forces? So we know the vertical forces equal each other, but what about the horizontal forces? What about force of friction and force of the wall? We know those forces have to equal each other because everything's in equilibrium. Everything is in equilibrium. So force of friction has to equal the force of the wall. What is the formula for force of friction? Force of friction is equal to the coefficient of friction times the normal force. So times the normal force. We're given both of them. I mean, we found normal force and we're given the coefficient. Coefficient is 0.425. And we're given the we found the normal force is 725.2. So force of friction is equal to 308.21 newtons. So that means the force on the wall is also 308.21 newtons. So now we got the net forces. But it's not just forces that are being balanced. It's the torques too. It's pretty much the angular force, not just the linear forces that are being balanced, the angular forces. So to answer this problem, you'll need to know a good understanding of what torque is. The formula for torque is equal to the force times the radius times the sine of the angle. Where the force is, force here. The radius is the distance between the pivot point and the force. And the angle is the angle between the radius and the force. So let's simplify that a little bit. Before that, important formula to know. What is the pivot point? we can actually choose wherever we want the pivot point. But we want our pivot point to get rid of as many forces as possible to make it easy for us. Our pivot point should be on top of as many forces as possible. If you think carefully, you'll realize that this point I'm drawing in brown, that's on top of both the normal force and the friction force. So what's the torque on the normal and the friction force? What's the torque of the normal? What's the torque of the friction? Well, torque of normal is just normal force times the radius times the sine theta. But what is radius? The distance between the normal force and the point. The normal force and the point are the exact same spot. That means the radius is 0. That means this entire thing, doesn't matter what everything else is, the torque on the normal force is 0. And the same logic applies to friction. The friction force and the rotating point are at the same. So the torque on friction is 0. So we can completely ignore normal force and friction force for torque for now. We need to look at these other forces though. We know if it's in equilibrium, the clockwise torque has to equal the counterclockwise torque. So the clockwise torque would be torque of the weight of the ladder plus the torque of the weight of the person, because these forces, both of them are pointing down. So if you point down, you would get a clockwise rotation for both of these. And the counterclockwise would be the force of the wall, because the force of the wall would go in a counterclockwise motion. So torque of the force of the wall. So let's calculate all these torques. Using the formula I boxed in red. So torque of the weight of the ladder. Well, that's the weight of the ladder times the radius times sine theta. So what is the weight of the ladder? And we can derive all the expressions. So torque of the weight of the ladder is equal to the weight of the ladder times the radius times sine theta. The weight of the ladder is over here, and the weight can be calculated as mass times gravity. So that's just the mass of the ladder, which is 14 times 9.8. What's the radius? What's the difference between this brown dot and the red arrow? That's going to be 3, because this entire leg is 6, and the red arrows are the center of mass, which is halfway point. So the halfway point of 6 would be 3. And sine theta, what is sine theta? Theta is the angle right here. So this black angle I just drew, that's theta, because that's the angle between the weight and the radius. The radius I'll draw in green right here. That's the radius. The red arrow is the angle. So if we draw the full triangle, we know that it's just opposite over hypotenuse. This triangle, if you've done similar triangles, you'd realize it's similar to this big triangle right here. 3.6, 6. So the opposite is 3.6 and the hypotenuse is 6. So, which is essentially what sine of theta is. So you can replace this with 3.6 over 6. Now solving all that, you would get 14 times 9.8 times 3 times 3.6 divided by 6. You would get 246.96 newtons. That's newtons meters. That's the torque from the weight of the ladder. 246.96. What's the torque based on the weight of the person? Torque based on the weight of the person is equal to the weight of the person times the radius times sine theta, just like normal. So the weight of the person is just the mass of the person, which is 60, times gravitational constant. What's the radius? In this case, the radius would be our answer, because think about it. If this green arrow, I'll actually remove the first one. This new green arrow is the distance between the brown point and the person. That's what we're trying to find. We're trying to find this green line. We're trying to find how far the person can climb. So let's leave that as x. And sine of theta will stay the same, because it will just be 3.6 divided by 6, because of the similar triangle I talked to you about before. So we can leave that as an expression. So 60 times 9.8 times 3.6 divided by 6. This would be equal to 352.8x. 352.8x. Finally, we want to find the torque applied by the wall. So let's bring this down a little bit. So we want to find the torque applied by the wall. So torque applied by the wall would be the force of the wall times the radius times sine theta. So the force of the wall, which we calculated to be equal to the force of friction, all the way up here, that's 308.21 newtons. 308.21 newtons. Times the radius. What's the distance between the brown point, this new green arrow I'm going to draw? What's the difference between this brown point here and the force of the wall? That's the full length 6 newtons. 6 meters. So you would get force times the radius. Sine theta. What is sine theta? This angle here will be theta. And because these two lines are parallel, this line here and this line here are parallel, we can use the alternating angles, like theorem from geometry, to realize that this angle here is also equal to theta. And because we're trying to find sine of theta, sine is equal to opposite over hypotenuse. So that's 4.8 divided by 6 times 4.8 divided by 6. So you would get 308.21 times 6 times 4.8 divided by 6. You would get 1,479.408. That's the torque applied by the wall force. So the final equation will be 246.96 plus 352.8 times x equals 1,479.408. Now it's just a matter of solving for x. This is the final equation. We solve for x, so we minus 246.96 divided by 352.8. X would be equal to 3.493 meters. So what does that mean? That means the person has to be 3.493 meters away from the brown point. So the answer to this question would be B, 3.49. Number 10. The siren of a police car at rest emits sound at a frequency of 1,550 hertz. The police car is chasing a speeder on I-20. If the police car is traveling at 150 kilometers per hour and the speeder is traveling at 120 kilometers per hour, what frequency does the driver of the speeding vehicle hear? So, and the air temperature is 20 degrees Celsius. So this question relates to the Doppler effect. So that's what you need to know for this question. So what is the Doppler effect? The Doppler effect states that the frequency observed changes based on the velocity of both the source of the sound and the object that's hearing. The way I could draw it is, let's just say, there's a radio. Let's just say there's a man, and he's yelling. He's yelling and he's like letting sound waves exit out of his mouth. And then you're all the way here, very far away. If you're at rest, you'll hear at a certain frequency. However, if you start moving, let's just say this green arrow is velocity. If you have velocity and you move towards the man, the frequency will actually increase. If you move towards the man, the frequency increases. If the man moved towards you, the frequency would also increase. And I'll just visually diagram this. So if this is you, you're moving towards the man. See the sound waves? The frequency is much higher. Same thing if the man, okay, I'll just like draw the whole thing, starts moving to you, the sound waves get much higher. So that's essentially the Doppler effect, that the velocity of the objects can change the frequency observed. So there's the formula to use that is the frequency observed equals the frequency of the source times the velocity of sound plus or minus the velocity of the object divided by velocity of the sound plus or minus the velocity of the source. So FO will be frequency of the object, or actually instead of object I'd say of listener. Fs would be frequency of source. I actually replace this frequency heard by the listener. And the Fs would be frequency of the source. V is the speed of sound, which we can calculate as V equals 0.6 times the temperature plus 331. VO is the velocity of the object, or velocity of listener. Vs is the velocity of the source, the sound source. So now that you got all the variables for what the Doppler effect is, let's solve the problem. So, one more big clarification most people struggle with, and probably I'd say the hardest part of the problem, is what's with the deal with the plus minus? When do we have to use plus and when do we have to use minus? Again, think of it like this. When the object, actually I'll diagram while I'm answering the problem. So with the Doppler effect in mind, we're trying to find the frequency of the observed by the listener, observed by the speeder. That's what we're trying to find. What frequency does the driver of the speeding vehicle hear? We know the resting frequency is 1,550. That's what's given to us in the problem. And what is the speed of sound? 0.6 times the temperature is 20 degrees plus 331. This is actually the one case where you can use Celsius, one of the few cases where you can use Celsius and not Kelvin. Calculating this, you would get the speed of sound to be 343 meters per second. So this would be 343, this would be 343. 343 plus or minus. What is the velocity of the object? That's the observed velocity observed or heard by the listener. The listener in this case would be the speeder. The speeder is moving at 120 kilometers per hour. Converting 120 kilometers per hour into meters per second. So 1 kilometer is 1,000 meters. And 1 hour is 3,600 seconds. So 120 divided by 3.6. The speed of the speeder is going to be 33.3 meters per second. And using the same method for the police car, but just to save time, I'll just do 150 times 1 over 3.6 to get 41.67 meters per second. This is the observed velocity, this is the source velocity. So this would be 41.67. Now let's get over with when to use plus or minus. Let's diagram the situation. The speeder I'll draw in red. This is the speeder. The police car I'll draw in blue. So the speeder is moving away from the police car, and the police car is moving towards the speeder. So if the speeder is moving away from the police car, And we know that velocity, the object right here, if I draw in green, the numerator talks about the object. So if the object is going away from the sound source, because remember the police car is a sound source. Police car is what's emitting the sound. If it's moving away from the sound source, you'd be decreasing the frequency. So which of the operations, plus or minus, would decrease the overall FO, would decrease the frequency? That would be minus. The police car is moving towards the speeder, so it would be increasing the frequency because now you would see this guy moving towards, that would increase the frequency. So one main thing is you would think it's plus because you're increasing the frequency, but if you increase the denominator by doing plus, you'd be decreasing the frequency. To increase the frequency, you have to decrease the denominator. So this would also be minus. So this is your final equation. And plugging everything in to a calculator, you would get 1592.9 hertz. That rounds closest to answer choice C, 1590 hertz. So the answer to number 10 would be C. Number 11. Des had a cabin near Flathead Lake in Montana. The cabin had a big glass window with a view of the lake. The window measures 2.22 meters by 1.11 meters and is 1.35 centimeters thick. On a cool summer morning, the temperature outside was 6 degrees Celsius and the temperature inside was 20 degrees Celsius. Find the rate of heat flow through the glass window. So, this one you have to memorize the formula for heat flow. Heat flow is equal to K, the heat constant, times the area exposed from the heat, times the change in temperature in Kelvin, divided by the length of just how far the heat's been transferring. So let's just define that. So H would be heat flow in watts. K is the heat constant. A is the area, cross-sectional area to be specific. Delta T is change in temperature. This would always be in Kelvin. And L would be length, which would be in meters. So let's diagram what's the problem's asking. In blue, we have a rectangular prism. So it's, I guess you would say something like this. There. So that's the glass window. And the red would be the heat. So on the outside, it's 6 degrees Celsius or 279 degrees Kelvin. On the inside, it would be 293 degrees Kelvin. If you don't know the formula to convert Celsius and Kelvin, 273 plus Celsius equals Kelvin. So you just add 273 to both of these temperatures here on the left side. And there's obviously heat flowing from hot to cold through the window. What do I mean by area? I mean what I'm shading in green right now. That's the area that's passing through. And what do I mean by length? I mean this part I'm putting in brown. So the green is the area and the brown is the length. So plugging everything into the equation. H equals K is 0.84. Area is what we know will just be the dimensions. 2.22 times 1.11. Change in temperature. What is change in temperature? We just subtract these two values. 293 minus 279. Actually, change in temperature you don't have to have in Kelvin. You'll get the same number, but just get into the habit of using Kelvin very often. Times change in temperature will be 14 because 293 minus 279. And the length. Remember, the length of this brown segment right here, that would be the width, 135 centimeters. Convert that to meters, that'd be 0.0135 meters. Plugging everything into the equation, you would get 2,146.592 watts. So the answer to this question would be E, 2,150 joules per second, or 2,150 watts. Number 12. If the current flowing through the 150 ohm resistor is 0.415 amps, find the value of R, which is this resistor right here. So if we combine both of these resistors, like if we combine the top resistor, we would just get one resistor of R1, of value R1. If we combine the bottom resistor, as both of them are in parallel, we would get R2. By combining, I mean by like using the parallel resistance formula, 1 over RT equals 1 over R1 plus 1 over R2. With this in mind, you realize that that all three of these resistors are in one line, so it's going to be a series circuit. So we know that the current flowing through 150 ohms is 0.415. In a series circuit, the current flowing through all the resistors is the same. That means the current flowing through resistor 2 is 0.415 amps. The current flowing through resistor 1 is 0.415 amps. And the current that just left the battery is 0.415 amps. Actually, I mean, we don't really need. So, with that in mind, what is R1? What is this value first? If I go back to, if I redraw this circuit right here, where I see the parallel circuit, I know that 0.415 amps goes through the combined amount. So what's the combined amount? Using the parallel resistance formula, you would get 1 over RT, which is the combined amount, equals 1 over 60 plus 1 over 90. With that in mind, solving for that would equal 36 ohms. So you would combine these two resistors to get one resistor of 36 ohms. So both of these would combine to get one resistor of 36 ohms. So we know a current of 0.415 amps flows through it. What is the voltage drop through this resistor? The formula for voltage drop is equal to current through the resistor times the resistance of the resistor. It's still Ohm's law. Voltage drop. So what's the current? Current is 0.415. What's the resistance? 36 ohms. That means the voltage drop is going to be 14.94. Voltage drop, so that means it would be negative 14.94 volts. 120 volts initially left the battery. We know 120 volts left the battery. after going through this resistor, it lost 14.97 volts. So that means the voltage after this resistor is 105.06. I'll actually go in green. So that's the voltage after the first resistor. What about the second resistor here? What's the voltage after the second resistor? Well, we actually can't find the second resistor yet because if we unshade it, there's an unknown. So we can't just use the resistance formula to find that. But we can find the voltage drop through this resistor. We know at the end of the last resistor, the voltage has to be 0 volts because there's nothing else. It's going to be 0 volts at the end of the battery. So initially there was some amount of voltage, but after the 150 ohm resistor, it drops down to 0. So using the voltage drop formula again, we do 0.415 equals 0.415 times 150. You would get 62.25 volts. That means the voltage right before the 150 ohm resistor is 62.25 volts. This voltage carries over to over here. Right after R2, the voltage is going to be 62.25. What does this mean? That means before, so let's draw, this is R, okay. Let's draw this. This resistor is R2. Initially, the voltage was 105.06 volts. At the end, it's 62.25 volts. So what is the voltage drop of R2? Well, you just subtract the two. So 62.25 minus 105.06. That means the voltage drop, actually when R2 wouldn't equal this. That's voltage drop. Voltage drop of the second resistor. So the voltage drop would be equal to negative 42.81 volts. So that's how much voltage that the second resistor absorbed. Using the formula V equals IR. V equals IR. Voltage equals current times resistance. Voltage drop is 42.81. Current is 0.415. And resistance is, we're trying to find that. Solving for R2, you would get, also wait, one more thing guys, I just realized we have a positive sign here. That's what we want because we're studying the voltage drop. So after we considered the sign right here, you don't need to look at the negative sign anymore. Once you use this formula, you don't want the negative sign, especially because if you do, resistance will become negative. So make that positive 42.81. If you can calculate the R2 to be equal to 103.157 ohms. So that's the total resistance of the second resistor. So if that's a total resistance, what was the resistance for the resistor we wanted to find in the beginning? If we reveal, actually, let's move these interrupting things. If we reveal the resistor, the parallel circuit, you would get R on one side and 180 ohms on the other side. You want to find R. That's the end goal, is to find R. So that means 1 over RT equals 1 over R plus 1 over 180. We know the total resistance is something we calculated. It's going to be 103.157. And solving for R, right here plugging everything into a calculator, you would get R equals 241.637 ohms. So the answer to this question is rounds up to 242 ohms. So the answer to number 12 is going to be D. Number 13. 2-point charges are separated by a distance of 24 centimeters. One has a charge of 360 nanocoulombs, and the other has a charge of negative 480 nanocoulombs. Point P is between both of these points on a line connecting the point charges, 8 centimeters from the negative charge. Find the magnitude of the electric field at P. So let's draw the situation out. So we have one point charge with the positive charge. You have a charge with a negative charge, and they're separated by a distance of 24 centimeters. And 8 centimeters from the negative charge, you have point P. Drawing green right here, point P. So point P has electric fields on it. We want to find the net electric field. You remember the properties of the electric fields. A positive charge releases an electric field that goes outwards. A negative charge releases an electric field that goes inwards. So if a positive charge releases one that goes outwards, I'll draw in a blue arrow. The negative charge makes it go inwards. Both arrows are lining up, so you want to be adding the arrows if you want to find the net charge, the magnitude of the net electric field. But what does the arrows mean? The arrows represent the electric field, which can be calculated in this formula. Electric field equals Coulomb's constant times the charge divided by the distance between the charge and the point squared. The electric field's unit is newtons per coulomb. Charge is equal to, when measured in coulombs, R is measured in meters, and K is given on your formula sheet right here. Coulomb's constant is 8.99 times 10 to the power of 9. So, with that in mind, let's go back to the question. The electric field generated by blue plus the electric field generated by red, or actually positive, negative. Let's say color coding. From the positive charge plus electric field from the negative charge equals K times, what is Q1? The charge of the positive charge is 360 times 10 to the negative 9. What's the distance between the positive and point P? That's 16 centimeters, which is going to be 0.16 meters, and you want to square that. Same method for here. If it's remember, using Coulomb's Coulomb's law, derivation of Coulomb's law, you do not want to use negative signs. You actually want to get rid of the negative signs. After you interpret the direction of the electric field, the negative sign isn't much use anymore. So what I would do, I would just get rid of the negative sign, just keep 480 times 10 to the negative 9. And the distance between the negative charge and the point is 8 centimeters or 0.08 meters, and then you want to square that. So now plugging everything in and making sure I substitute K in for both of these values, you're going to get you would get an answer of 800,671 newtons per coulomb. So this is the answer to the question, which rounds up to 801,000 newtons per coulomb. So the answer to this question is going to be letter E, 801,000 newtons per coulomb. Number 14. A thin 18 centimeter long solenoid has a total of 750 turns of wire and carries a current of 4 amps. Find the magnetic field inside near the center. So this is just a variation of Ampere's law. To find the magnetic field inside a solenoid, you would use this formula. Permeability of free space times the current times the number of coils divided by the length of the solenoid. So B would be magnetic field in teslas. I would be current in amperes. N would be number of turns. And L would be length of the solenoid in meters. And what is this weird U with an O symbol? That's called the permeability of free space. You find that down on your useful constants page. It's permeability of free space. 4 pi times 10 to the power of negative 7. So, going back to the question. Now we have everything we need to solve this question. The magnetic field in the inside is equal to the permeability of free space times the current, which is 4 amps, times the number of turns, which is 750 turns, divided by the length of the solenoid, which is 18 centimeters, but you can convert that to 0.18 meters. Plugging everything into a calculator, you would get 0.021 teslas. But you want your answer to be milliteslas. So remember, teslas to milliteslas, you have to multiply by 1,000. So or actually, I'll write that as 0.02094 teslas. So that would also equal 20.94 milliteslas. So the answer to this question is 20.94, or rounds up to 20.9. So the answer of P12 is going to be 20.9. Number 15. A metal rod makes contact with 2 parallel wires and completes the circuit. The circuit is perpendicular to a 125 Tesla magnetic field coming up out of the page. The resistance is 24 ohms. If the rod moves out of right at a constant speed of 1.22 meters per second to the right, find the current induced in the circuit. Induced current. So, to start with this problem, you'll need to know this formula. Induced EMF equals magnetic field times the length of the rod times the velocity of the rod. So this would be induced EMF, electromotive force. It's another word for voltage. Induced voltage, essentially. B is magnetic field. Also, induced EMF, the unit is going to be volts. Magnetic field, the unit is going to be teslas. L is the length of rod in meters, and V is going to be velocity in meters per second. So this is what you need. So, do we have everything? Do we have the induced EMF? Do we have magnetic field? Do we have the length of the rod? And do we have the velocity? The magnetic field is 1.25 Teslas. It's given to us. The length of the rod is. I know it might seem that you're thinking of the distance between the wires. By length of the rod, I mean the length of the rod that's like between the wires. This part. That's 36 centimeters or 0.36 meters. And the velocity of the velocity of the rod is 1.22 meters per second. So solving this out, you would get 0.549 volts. That's the induced EMF on the rod. So, if that's the induced EMF, we were trying to find the induced current. So we know the Ohm's law, voltage equals current times resistance. Because induced EMF is essentially voltage, it's essentially voltage, induced voltage, we can just replace voltage with induced EMF equals IR. So then I equals induced EMF over R. So you would get 0.549 volts divided by a resistance of 24 ohms. Divided by 24, you would get 0.0228. So that's how many amps you're gonna get. But you want to find that in milliamps, so you multiply by 1,000. 22.88 milliamps, or 22.9 milliamps. So the answer is 22.9 or letter B. Number 16. A converging lens with a focal length of 18 centimeters is placed in contact with a diverging lens with a focal length of 24 centimeters. What is the focal length of the combination? So if two mirrors are placed right next to each other, and you want to find the combined focal length, the formula to find that would be 1 over the combined focal length equals 1 over the first focal length plus 1 over the second focal length. So in this case, 1 over FC would equal the first focal length, let's just say, is 18 centimeters. Normally, I say the standard unit for length is meters, but in this case, it actually wouldn't matter whether it's meters or centimeters because everything would cancel each other out. So you're going to be left with centimeters at the end. So it doesn't matter if you convert to meters or if you keep it at centimeters. The first focal length is 18 centimeters. The second is negative 24 centimeters. So plugging everything in, you're going to get 1 over FC equals 1 over 18 minus 1 over 24. 0.01389. And you're trying to find FC, so FC would equal 1 divided by that, or 72 centimeters. So the answer to this question would be E, 72. Number 17. Consider a metal target with a work function of 2.4 electron volts. What is the threshold wavelength of light that can cause photoelectric emission from the target? So when we're talking about the photoelectric effect, the work function is the minimum amount of energy needed for electrons to be ejected from a piece of metal. So if you have a piece of metal and we shine light down this metal, electrons will be ejected. But the light has to have a certain amount of energy. Once the light attains this amount of energy, electrons will be released. So the certain amount of energy that's needed to release electron is called the work function, which is given in the problem, 2.4 electron volts. So the light that hits the surface has to have an energy of at least 2.4 electron volts. So we're trying to find the threshold wavelength is exactly 2.4 electron volts. So 2.4 electron volts, if we convert that into joules, given the sheet down here, we can circle this. An electron volt is 1.602 times 10 to the negative 19. 1 electron volt is 1.602 times 10 to the negative 19 joules. So converting this into joules, you're going to get 2.4 times 1.602 times 10 to the power of negative 19. You're going to get 3.845 times 10 to the negative 19 joules. But that's the threshold energy. That's how much, this is the minimum amount of energy for light that the light needs to eject electrons. But we want to find the minimum wavelength. We use two formulas for this. The first formula is energy equals Planck's constant times frequency. The second formula is the speed of the particle times wavelength times frequency. So I'll define everything here. E is energy in joules. H is Planck's constant, which is given on the formula sheet. Planck's constant's over here. So it's 6.626 times 10 to the power of negative 34. Frequency is measured in hertz. Wavelength is measured in meters. And velocity is measured in meters per second. So now that we have all our measurements, these are the two formulas you need to know. So we know the minimum energy is equal to 3.845 times 10 to the negative 19 joules. So 3.845 times 10 to the power of negative 19 equals Planck's constant times frequency. We use this formula at the top. We know velocity equals wavelength times frequency. We can divide both sides by frequency to get wavelength equals velocity divided by frequency. Or actually divide both sides by wavelength to get frequency equals velocity divided by wavelength. Plug that down here to get Planck's constant times velocity divided by wavelength. Now, a key thing to realize is that these light rays, they're light rays. They go at the speed of light. So the velocity of the light is 3 times 10 to the power of 8 meters per second. I think that's a given constant. Yeah, speed of light in a vacuum. So speed of light is 3 times 10 to the power of 8. So, and we're trying to find wavelength here. So we have everything we need to know. Let's erase this. We have everything we need to know now. So substituting for wavelength equals Planck's constant times the speed of light divided by 3.845 times 10 to the negative 19. So using the two constants that were given, I'll circle them in green. Planck's constant, speed of light. Plugging those into this equation, you're going to get a wavelength of you get a wavelength of 5.169 times 10 to the power of negative 7 meters. That's the wavelength you get. However, you want your answer to be nanometers. So how many nanometers are in a meter? There are 10 to the 9th nanometers per every meter. So 5.169 times 10 to the negative 7 meters. For every 1 meter, there's 10 to the 9th nanometers. So multiply this by 10 to the 9th, you would get 516.98 nanometers. So the final answer is going to be 516.98 nanometers, which rounds up to 517 nanometers. So the correct answer for number 17 is going to be 517 nanometers. Number 18. Complete the beta decay reaction. So we know the number, for this question we want to count the number of atoms and the mass of the object as well as the proton number. So the top number is the mass, or the number of protons plus neutrons. The bottom number is just the number of protons. So as you can see, the magnesium lost one proton and went to sodium. It lost a proton, meaning it had to have released a proton. So a proton, it may not release a proton because the mass does not change. So the mass stays the same, but it releases a positive charge. So it essentially releases a positively charged object, which in this case would be E+, because E+ is the only positive charge in this entire equation. So the answer to number 18 is going to be D. Number 19. Nathan was doing a lab in which he released a 400-gram mass at various heights above a vertical spring. He recorded and plotted the heights as well as the compression of the spring. So these are the two variables. And used a table to find the spring constant of the spring. So this problem is relating from height and compression. So you would use a conservation of energy type of problem for this. So if we have a spring, just draw that in blue, we have a spring. And we're dropping an object on the spring at a certain height. At a height, the object has potential energy. Potential energy is defined as the mass of the object times the gravitational constant times the height of the object. At the end, the object falls onto the spring and it compresses the spring. So the spring is going to be much more compressed as the object falls on it. At this point, the object would have potential energy. It would be called elastic potential energy. And the elastic potential energy is defined as 1/2 times the spring constant times the amount of compression or stretch squared. In this case, it's compression. So 1/2 times the spring constant times compression squared. So since the law of conservation of energy says that the total energy before equals the total energy after, and that potential energy is the only thing before, and elastic energy is the only thing after, you could relate mass times gravity times height equals 1/2 kx squared. With this in mind, you want to solve for the spring constant. So you want to solve for k. Get k to one side. So 2mgh over x squared equals k. And now you just want to plug in the values from both the table, both from the chart and what you already know. You already know that the mass of the block is 400 grams. And since the standard unit of mass in physics is going to be in kilograms, you want to convert this to kilograms. 0.4 kilograms. Gravitational constant is 9.8. And we want to find height and this compression squared. So to find this, you take a point on this graph. I'll take this green one that I'm shading right now. I'll use that point. The height above the spring is 10 centimeters, and the compression is going to be 25 millimeters. So the height above the spring is 10 centimeters or 0.1, because 0.1 meters is equal to 10 centimeters. And 25 millimeters is equal to 0.025 meters. So plugging everything in, you would get 2 times 0.4 times 9.8 times 0.1 divided by 0.025 squared. You would get a spring constant of 1,254.4 newtons. So you get a spring constant of 1,254.4 newtons per meter. And because of these graph questions, the points are, you're kind of estimating that this is 25, this is not actually 25. You're not going to get an answer that's directly close to one of these, like directly one of these. So you have to like choose the closest answer. So 1254.4 is closest to 1300. So the answer to number 19 would be 1300. Number 20. The capacitors are both uncharged at t equals 0. The switch is closed at t equals 0. Find the current in the circuit at t equals 12. So we know this is an RC circuit. And what an RC circuit is, it's a circuit that has a resistor and capacitors. So, to diagram the circuit, we want to first make these two capacitors one capacitor. Just like how we would to a resistor, we want to find total capacitance. Now, you might see that these capacitors are in series, and you would think that because just like a resistor you would, in series you would just add the resistors up. In reality, for capacitors, it's actually inversed. In series, you want the total capacitance is the reciprocal of the sum of the reciprocals of the capacitors. And in parallel, the total capacitance is the sum of the capacitors. So this is the opposite to resistors. In series, resistors would be the sum. The total resistance would be the sum of the resistors. And in parallel, it would be the sum of the reciprocals. So these are the two, that's the main difference between capacitors and resistors. So to add these two series capacitors up, you would use 1 over CF. So 1 over CT equals 1 over 240 plus 1 over 240. So total capacitance would be 120 microfarads. So we can erase this entire thing and replace it with the capacitor of 120 microfarads. Place it, I should know, it's capacitor. Symbol for capacitor is this, so replace that with capacitor of 120 microfarads. Now that you only have one resistor and you only have one capacitor, now we can actually solve the circuit. So let's move everything upwards a little bit. So to solve the circuit, you would need to use this formula. Voltage in the capacitor equals voltage, I'll just write voltage final. Voltage in the that's inside stored in the capacitor is equal to the voltage stored in the battery. I'll write as voltage initial times 1 minus e to the power of negative t over the time constant. So I should write that. So VF is voltage in capacitor. I would think of it as a final voltage because I'm just used to thinking of final and initial. VI would be voltage in circuit. The voltage that's actually stored in the circuit and the resistors and all. T is time. And capital T is time constant, which is equal to the resistance times the capacitance. That's why it's called an RC circuit, because it's resistance times capacitance. So let's solve this. VF is what we're trying to find. The initial voltage is 60 volts. 1 minus e to the power of negative. We want to find the current after 12 seconds. And what is the time constant? Time constant is resistance times capacitance. The resistor is 120 ohms, and the total capacitance is 120 microfarads. So 120 times 10 to the negative 3. So solving for time constant, you would get 14.4 seconds. So now you put 14.4, and now solve for this, you would get the voltage in the capacitors. So negative 12 divided by the answer e to the power of the answer, 1 minus the answer, times 60. So the voltage at the end in the capacitors is going to be 33.924 volts. But you don't want to find the voltage in the capacitors. You want to find the voltage in the circuit. Well, we know the voltage in circuit plus voltage in the capacitors equals the initial voltage. Equals initial voltage. So we know, and we're trying to find the voltage in the circuit. The initial voltage was 60, and the voltage in the capacitors was 33.924 volts. So 60 minus 33.924, you get the voltage in the circuit would be equal to 26.07 volts. So that's the voltage in the circuit. But you don't want to find voltage in the circuit, you want to find the current in the circuit. So now it's a matter of using Ohm's law. Voltage equals current times resistance. Current in the circuit is equal to the voltage divided by resistance. So current equals voltage divided by resistance equals, so voltage is 26.07, the resistance is 120 ohms. You would just solve for this to get the answer. So V over R is equal to that number divided by 120. You would get 2173 amps. And you want your answer to be milliamps, so you convert amps to milliamps. Anytime you're converting base to milli, you're multiplying by 1,000. 0.2173 times 1,000 equals 217.3 milliamps. So the answer to this question would be A, 217 milliamps. And we're done with number 20, and we're done with the entire exam. So if you had started from biology to chemistry to physics, you'd be done with the entire test by now, all 60 questions. So I hope you found this video useful, and please let me know in the comments if you have any doubts or any suggestions you think I should make about any of the questions, and I'll be glad to respond to them. If you like the video, consider dropping down a like and a subscribe button. It would help me a lot, and I'd really appreciate it. I hope I could see you guys in my next virtual challenge meet video, where I'll be covering the biochem and physics for that virtual challenge meet.